Good morning. Last day we started filter separation, cyclone separation, other part. So, from here I will continue today. Cyclone separator, actually cyclone separator is one device where you have one conical shape or maybe parallel shaped system and fluid will be entering tangentially. Okay, we discussed in the last day. Fluid will be entering tangentially, like this picture you can see top one. Here fluid is entering and it will be rotating. When it is rotating, it will be rotating continuously and it will be going down. Okay, it is rotating continuously, it will be going down. Now, the high density particles will have larger radius. Okay, and low density particle will have lower radius. Why? Because when both are rotating together, so high density, because of mass, it will be trying to move further away from the center core, and lower density it will try to go, but high density fluid will have already taken that space. So when it is rotating, high density fluid will touch the surface on the device surface, and it will not give space to the low density fluid. So what will happen? Low density fluid will not touch this separator surface or device surface, and it will be rotating at the center core. From center core you put one pipe, okay, and you suck this low density fluid. Low density or low gravity fluid you suck from here. Okay, so in that way you are separating, and high density fluid you are getting here, or you can see this high density fluid you are getting here. Okay, so in that way you can separate two fluid, let us say solid and liquid, liquid and gas, even two liquids also with different densities possible to separate using this mechanism. But there is one problem, this is very much sensitive to the flow velocity and pressure. So if you do not maintain proper flow velocity, separation will not be proper. So it is required to have a good flow velocity. Flow velocity means actually you have to maintain certain pressure. The pressure drop will also be high. Again, this separator is not having a rotating part or moving element, so life is longer actually. If we use centrifugal separator using some mechanical means, life will be longer. Here in this case life is smaller. So all the separator system, other mechanical equipment which are static in nature, the mechanical equipment, there is no relative movement, that their life will be longer. If there is any relative movement between two mechanical machine parts, then there will be any friction, wear, tear, some other issues. Because of that, life will be shorter. So the designers will try to reduce number of moving elements or relative moving element, so that system life will be longer. Now we have seen horizontal, vertical and spherical separator. Because of this spherical separator small use, we are not discussing or we are not differentiating among these three. So just we are focusing on horizontal and vertical separator. These are most commonly used in the surface or offshore production systems. So horizontal separator, if I divide like this, horizontal separator is smaller, okay, smaller in size, less expensive and less liquid surge, more plan area, means side area will be more. Okay, this is more plan area you are getting. So larger liquid capacity, best suited for liquid separation, foaming crude, best suited for liquid separation, foaming liquid. Okay, so foaming liquid means like if foam is there, if you are giving lots of surface area, then foam will be broken or two particles will be colliding each other and it will make separation proper. So in that case, horizontal separator is better because you are getting more surface area. Surface area means like if this is a separator and if this is this is liquid, liquid means oil plus gas, oil plus water, this is gas. Okay, so we are getting lots of surface area here. But if you have vertical separator, your surface area is this one, okay, smaller surface area, okay. This area I am indicating, this area is more for horizontal separator. So, that is why foamy crude will have better performance. But if you see vertical separator, in that case better in handling solids, better in handling. So, solid particle will be slowly moving down and it will be settling here, because it will be more calm zone and this is more turbulent zone. So, if fluid, gas and liquid interface will be more turbulent zone, but if you see the bottom area, so there will be more calm zone. So, their settlement will be better. So, solid will be settling quicker and better way, less plan area. So, this is from side, it is having less plan area, okay. Then horizontal separator, this point is important for offshore application, okay. So, because if you need very large space, offshore will be very compact area, actually deck area or semi submersible, any other platform, surface the separation area will be very small. So, in that case you need a smaller compact system. So, in that case vertical separator may be better, okay. So, relief valve and other less plan area, and for this is for important, this is important for offshore area, offshore application, okay. And relief valve and some of the control may be difficult to put. Relief valve etc. can be difficult to put, but anyway these are safety device, so you have to put anyway. The vessel may have to be removed from the skid because it is very tall, so it can be toppled. So, you have to remove from skid. Okay, then you can use. So, this will be better. Okay, so till this time I discussed basically a vessel. It is having inlet flow. I have shown you mist extractor, okay, mist extractor and your control valve here, and basically two phase I have shown. So, there will be valve, dump valve, this is called dump valve, and it will be controlled by level controller, okay. So, it will be like this LC, okay. So, level controller, okay. This is pressure controller, okay. This is liquid means water and oil mixture, this is gas, okay. So, but this is not actual case. Actual case will have, there will be many other items like splash guard, inlet diverter, defoaming plate, vortex breaker, mix extractor, mix salinimeter, there will be some more items. So, this is a basic equipment I will discuss here. So, let us say one by one. Splash guard. What is splash guard? Splash guard means like say, okay. So, splash guard actually it will be reducing turbulence and it will be creating a laminar zone. For example, let us say we have one vertical separator, okay. You have inlet diverter, we already will discuss further again this inlet diverter, and this is inlet flow, INLET, inlet flow, okay. So, when inlet flow is coming, it will create loss of turbulence, okay, and it is creating, let us say this space, and you have water out, okay. Let us say you have oil you are taking out like this, water you are taking out like this, and you want more calm zone for water outlet. So, that oil particle anything is there that can be separated, or you are creating less turbulence. So, you are creating one guard here like this. Okay. So, it is creating it is minimizing agitation, or turbulence, okay. so that particle sand maybe will be settling quickly, so slowly it will be settling at the bottom, water particle will be creating small path and it will be moving up. So water without heavier turbulence you are taking out. Okay. So this is called splash guard, inlet diverter. Inlet diverter already I have shown here, this one inlet diverter. Okay, this one inlet diverter, you can see this one I am drawing here. Okay. So inlet diverter, actually this will be diverting when fluid is coming. So inlet diverter, when fluid is coming from the inlet pipe, so it will be diverting flow and it will be pushing downward, so that high density particle will go down and low density particle will try to move up. Okay, and it will be going through mist extractor or gas outline. Okay. So this is called inlet diverter. So there will be different shapes of inlet diverters. For example, one shape will be like this. One shape, okay, inlet diverter. Okay, one shape can be like this. You have separator, it will be curved. Okay, so fluid will be splashing, it will be going down. Okay, this is inlet diverter. And another shape can be like L shaped. So they are in vertical separator I have shown L shaped, like it will be like this. Okay, entering, this is inlet diverter. Okay, this is inlet diverter. So it will be helping to control the emulsion of foaming into the vessel by directing it down along the side wall. It minimizes disturbance when gas and oil or fluid, liquid and gas is getting separated. Okay, so some will be tangential baffle like L shaped thing, some will be like smoothly it will be diverting, so it will be curved feature will be there, so that liquid will be going down and gas will be going up. So it changes the direction of flow by absorbing the momentum of the liquid and gas to separate in horizontal separator or vertical separator. Okay. In many cases there will be downcomer in vertical separator, I will discuss later. Okay. In some separator there will be sand jet mechanical equipment. So sand jet will be like, if sand is getting deposits of the bottom of the separator, so a jet you create and remove the sand and you push out from the separator system. So there is a sand jet system. Sand removal system or sand jet and drain is used to remove solids which may accumulate at the bottom of a vessel. Okay, defoaming plate. Okay, now see the defoaming plate. So foam, what is foam actually? Foam is actually gas particle covered by liquid, coated by liquid. Okay, so those two gas particle will not touch each other because it is coated by liquid. Okay, so it is creating like, it is liquid surface, is gas, so it is creating small different size of particles will be covered like this and it will be creating foam. Okay, when foam is created, let us say this is my separator. Okay, foam is taking lots of space actually, so your separation efficiency will be dropping. Okay, and gas, when liquid or gas entering, foam is taking lots of space, gas cannot go out and separation efficiency will be down. Okay, and coalescence will be reduced. Okay, so merging of two particle will be difficult if foam is there, and foam is created because of viscosity high, this foam will be created. And it is also possible that impurities are there, so aspartame and other thing, it will create again foam, and pressure decreasing also it will create foam. So if you can remove all this criteria, then foam will be reduced. If you are unable, then you have to create some defoaming plate or mechanical arrangement. Some you can add some chemical also, but chemical will be expensive process. So easiest way is to create a mechanical arrangement. Mechanical arrangement defoaming plates means like different plates, say 1 plate, 2 plate, 3 plate you could create with angle, with certain angle. So when you are creating plates certain angle and fluid is flowing through this, the particle will be colliding each other, the gas particle actually, when it is moving and closer to each other, so particle will be colliding. When they are colliding, gas bubble will be creating bigger size means they will burst quickly and gas will be released, liquid will go down. Okay, so this is called defoaming plate. Okay, so defoaming plate will be like this. If I draw like this, it will be like separator, and deforming plate, you create lots of deforming plate. When fluid, liquid or gas mixture is going through this one, particle will be colliding, gas particle or gas bubbles will be colliding each other, it will make bigger bubble again it will get bursts after certain size, because surface tension will change and your gas will go to gas line and liquid will be deposited there. So, that way you are increasing your separator efficiency. Vortex breaker. What is vortex breaker? Vortex breaker is that, like if you have one pipe, okay, and water it is sucking, okay, let us say the water level is here and water pipe is like this, water is going through this pipe, okay. So, what happens if water level is not so high, then it will create lots of vortex. When it is creating vortex, it will suck air, air will be sucked, okay. So, similarly your surface system, you have let us say water outlet line, okay, and if your water layer is here, so and if you are not maintaining this vortex breaking system, then what will happen, it will create turbulence, it will create vortex, okay. When it is rotating and it will be creating one funnel like system, okay, and funnel center core will be sucking air in separator system, gas will come, okay, and it will go to your liquid line, maybe water or oil. So, you have to put some vortex breaker. You can see the top picture I have given, it is one type of vortex breaker. You can put some flat plate also as a vortex breaker. You can there are several types of designs available, but if you put let us say this is a liquid surface and you put some flat plate over it, so then this, if you rotating, it will not suck air because it is blocking the air path, okay. Or you can create some mechanism like this, let us say this is your pipe, okay, this is your flow area, okay. You can create one flat plate here, so that fluid will be sucked from here, or you can create wider entry, okay, so that fluid will not create vortex, or if it is trying to create, it will be blocked by certain flat plate or some other arrangement. So, this is called vortex breaker. If you are not giving vortex breaker, because of high when fluid, liquid or oil, water is going out of the separator, it will create vortex, gas will go out through the line. So, your main purpose of separation is gone, okay, system will not work. Okay, many times I said that mist extractor and mist eliminator is there in almost every separator. So, what is that? Actually, it will be like woven metallic mesh, okay, woven metallic mesh. So, when liquid mixed gas is going through this one, liquid will be touching this mesh wire and it will try to create bigger particle, it will fall down, okay, and only gas will be passing through this one. So, this is called mist extractor, a mist eliminator or demister. So, many terms are there. A device used to collect small liquid droplets, okay, moist or hydrocarbon, maybe water or maybe hydrocarbon coated particles, they are moving trying to move out through the gas line from the gas stream. Before leaving the separator, it will be, you have to put, and the particle will be growing bigger and it will be falling down, okay. Wire mesh, so there will be many types of systems, like wire mesh will be there, wire mesh, centrifugal device will be there, there can be vent type separator system, mist eliminator system. So, vent type is like this, you create vent like this, okay, and when gas and liquid mixture together flowing through this, liquid will be passing through these narrow channels. When it is passing through the narrow channels with low velocity, so liquid particle will try to join together, it will try to make bigger particle. When bigger particle it is making, so it will try to slide down and gas particle will move up. So, this is called vent type separator, okay. So, vent type like this type of thing, and it you can create some angle, so that when gas and liquid is going out, so gas will be moving, trying to take the upper space, liquid will be trying to take lower space. Lower space means the liquid particle density will be more, okay. More density means number of particle will be more, and number of particle more, collision rate higher. Collision rate higher means it will make bigger particle means it will slide down and gas will try to move up. So, in that way you are separating liquid and gas, okay. This is called mist extract wave breaker. Okay, wave breaker is like this, like if you have offshore platform or anywhere your separator system is shaking. So because of shaking, you will create like wave. You see this bottle, water is there, half filled. Okay, so fluid will be moving like this. Okay, if small shaking is there, a big shaking is there, then you can, things will not work. But small shaking is there, still inside water you can see it is creating very large waves. If you have large waves, then actually things will not work. How? Let's say I have one horizontal separator. Okay, you are creating large wave and you have level controller. So level controller will get confused, it will not work. Okay, or you have interface controller. Okay, so there also the same issue will be coming if you have wave. So you have to put wave breaker. So what is the wave breaker? Wave breaker actually you put vertical plates. Okay, this is my separator, let's assume, and you put vertical plates. Okay, so if any wave is coming, it will not reach to the another section of the separator. So only local small wave can be there, but not a big wave. Like you can see this one end, small movement of this bottle is creating big change in liquid level in the another end. Okay, but if you have small lots of vortex breaker, then this level change will not be significant. So what is this? So if I draw one 3D picture like this, okay, okay, this is your liquid level. Okay, and I'll put level controller like this. Okay, and from side if I see, it will be like this. Okay, and you put lots of pores. Okay, so you create resistance when fluid is trying to move up freely, move one point to another point freely. You are giving some baffle plate or vertical plate, and you give lots of pores. So fluid will be passing through this, but it will be passing slowly, so it will not have so much motion inside the vessel. Okay, so you are creating resistance, creating hole to create. Okay, so wave may result from surge of liquid entering the vessel. Nothing but perforated baffle. This is perforated baffle. This is called perforated baffle plate. Okay, that are placed perpendicular to the flow. Okay, wave action should be eliminated, then level control will work. Okay, level switch or where anything is there, if wave is there, things will not work, or it will be giving wrong signal to your sensor, or oil line will give water line will give oil. So that sort of many issues will be coming up. So you have to put wave breaker to reduce waves. Okay, next thing is the downcomer. In vertical separator, many cases you have inlet diverter. Okay, in many cases you will not have inlet diverter, you will have downcomer. How this downcomer works? It will be looking like this. Okay, then okay, maybe where, and it will be like this: water, oil, gas. This is also gas, mist extractor. Okay, and water out, this is oil, this is called wear. Okay, this is called downcomer. This long pipe is called downcomer, and this is called spreader. Okay, so downcomer, actually instead of inlet diverter, people will be putting downcomer. Let's take fluid, it will pass through this pipe. Okay, then it will go to spreader. Spreader is actually flat plate type thing, and lots of pores will be there, holes. Okay, so smoothly you are spreading liquid or gas, whatever things are there, in the water zone. Okay, oil water interface nearby, you are putting this spreader. so that whatever oil and gas is coming, so they will have water wash. Okay. So to do why water wash? They say liquid gas, everything coming to your spreader and it is going out. Okay, it is going out. Okay. Now gas particle will go up anyway, but liquid particle, so oil is there. So oil will have lots of water particle. Now what they are trying to do, like if you have water particle in oil or oil particle in water, so oil particle will try to move up. When oil particles trying to move up, so it will try to take some water also. So what will do, you put inside water zone, so water and water particle, it will create bigger particle. So when you are creating bigger water particle will not try to move up, but oil particle will try to move up. Okay. So in that way you are trying to separate water and oil properly. Okay. So its location should be nearby oil and water interface. Okay. But inlet diverter, it try to separate liquid and gas, but in this case you are trying to separate actually oil and water. Gas anyway it will be separated, and one chimney will be there here, one chimney, CHIMNEY, chimney will be there. Chimney will be equalizing pressure inside this gas, oil, water zone and outside zone. Okay. And one weir normally is used. So weir, like this is oil will be overflowing through the weir and you are taking oil out. So this can reduce the use of your level controller. Okay. Weir reduce importance of level controller. Okay. So spreader location should be interface area, and you can use weir also. If you are not using weir, so then you have to use on level controller. One chimney should be there so that gas will be equalizing constantly, and in this case your inlet diverter may not be there.